Hey there guys, Peter here, and today I'm back with Game Maker Studio, continuing the effort of making an actual game. It took me a while, but I'm back and I'm trying to revive this series. It's not dead and I'm not abandoning it, at least for now. Alright, before we jump in, let's talk procedural generation for a moment. In short, procedural generation stands for a generation of anything, be it levels, items, encounters, etc., that is based on a certain set of rules. You can, and probably it's a good idea to say that the procedural generation is following certain procedures, hence the name. Anyways, it has become quite popular as of the last 5-6 years, ever since Minecraft became a thing and showed the world how a set of numbers and letters can be used to create virtually infinite amount of content for a game. Even before that, games like Diablo 2 has been using procedural generation in multiple ways to create its dungeons and loot and enemy encounters, and so on and so forth. Now, what I'm going to do is closer to the Binding of Isaac implementation than Diablo 2 or Minecraft. I'm going to use a string of symbols, also known as seed. Based on this seed, I will tie all dungeon properties to this row of symbols. Just like the Binding of Isaac, I'll create the level in each dungeon, I'll create the loot, the enemy encounters and everything else. There are multiple ways of doing this, but I'm going to use probably the easiest and simplest one. I'm going to just use the ASCII code of each character, and with some basic mathematic equation, I'm going to bring those numbers into certain limits. Now, more complex the equation is, the larger the variety of results will be. One rule though, there should be absolutely no randomness. The procedural generation must follow a strict set of rules and uses no randomness whatsoever. This allows the same seed to give the same result. You want to replay the same level, enter the same seed and you'll get the same level. The strict set of rules also helps define all the edge cases and limits the generation in certain range. I'm going to use Isaac as an example again. In the Binding of Isaac, you don't really want to have 50 or 60 rooms on a single dungeon floor. You want to play a few rooms, you want to have a few battles, get a couple of items, beat the boss and move on to the next level. But you want to have those few encounters, you don't want to just have 2 rooms and that's it. You as a player want to play the game, so the developer has to balance the generation results in order to have enough rooms to provide enough gameplay, but not too many rooms so to bore the player with 50 rooms on the same floor. So this is what the devs need to do to balance the procedures of the generation. Okay, so let's dive in and I'll see what I can do with that. This episode I'll just demonstrate how the basic procedural generation system works. So I have an entirely empty project. I've just made a couple of sprites here for a dungeon wall and for a dungeon chest. I'll make another one now, very quick, for a human. There we go, that's our human. He will also be in the dungeon. So we have 3 things. We have dungeon wall, we have a chest, loot chest, and we have an enemy. So we'll generate the locations of those 3 things in our system. Will generate the size of the dungeon and the amount of levels and everything else, and we'll generate the amount of chests and the locations of the chest, and we'll also procedurally generate the locations of each enemy. This is, let's say this is an enemy. It's a funny kind of enemy, but it's still an enemy. Right. We'll need just one object, and this object will be object proc gen. Right? It doesn't need a sprite. Okay, first we're going to start with the create event. So the first thing we need in the create event is seed. The seed is just a string. That's it. The seed is just not minus equals. The seed is just a string of letters and numbers and maybe some special symbols. Maybe not. We can restrict that with the integrated functions in GameMaker. Then we're going to need our generation data like floor count. It's not going to be floor count. Floor is an integrated function in GameMaker that rounds a number, so we don't want to use floor anywhere. We're going to use level count. Level count. We're defining it as 0. Then we're going to need level size. There we go. We're going to define that as 0 as well. We're also going to need chest count. Chest count. Count currently will be equal to 0. We're going to also need enemy count. Will also be equal to 0. This is just the setting up for our procedural generation system. Those are the 4 things we're going to generate using the seed. So, first things first, we need from the player, we need the seed value. So we have get string, there we go. The getString function has 2 variables in itself. One of them is str, which is basically going to be the message we're going to see in our pop-up box, and the message is going to be please enter a 4 symbol seed. And the next up is a default seed, which will be if the player doesn't enter anything, this default seed will be the seed that we'll have. And I'll just go into use 1, 2, 3, 4 as a default seed. Now we already have told the player we need a 4 symbol seed. So what I'm going to do to make sure we have a 4 symbol seed is while string get string length. Yeah, it wasn't string get length, it was just string length. And we don't even need this thing, we can just do that for seed. Well, string length of the string seed is smaller than 4. Actually, it's going to be not equal 4. So if the seed it has a different size than 4 digits, 4 characters, we're going to ask the player to enter seed. So we have seed equals getString. Alright, now for debugging purposes, I'm going to create a draw event. In the draw event, I'm going to draw text. I said text. X10, Y10. String. The string is seed text x all right, 18 y 10 seed. There we go. Now we also need a room, and in that room we're going to place our object, and we'll just test it out. The best thing you can do when you're programming things is testing on every step. 1 2 3 4. Okay, seed 1 2 3 4. Alright, so far so good. Now if I change the seed from 1 2 3 4 to 5 6 7 8, it will just say seed 5 6 7 8. That's fine. Now I'm in my object. I'm also going to add one extra event, which is when I press space. There we go. I will have game underscore restart. There we go. Just so I don't have to start the game every time I want to enter a new seed and test a new seed. So okay, now it's 1 2 3 4. When I press space, it asks for a new seed. I'm entering 5 6 7 8, and now the seed is changed to 5 6 7 8. So it's working. Everything is working perfectly fine so far. Right, I'm going to save this project for now and go back to the create event. Oh, I haven't tested this thing. Alright, let's test this thing. So currently we have a 4-digit seed. If I enter a 5th digit, it doesn't do anything, it just asks for another seed, just as we told it to do. We're just asking for a new seed. Now, after the player has entered the string, we're going to do something else. This is polishing work and it's not necessary to be done right now, but I just want to do it for my own OCD sake. So we're going to check if string length probably would have been faster if I typed that seed is not equal 4, and then we're going to have a show message, yeah, and the message will be the seed needs to be only 4 symbols long. There we go. Now if we test this, 1 2 3 4 is whoop. Okay, okay, so not equal 4. I put it on the wrong place. So let's test it now again. Okay, 1 2 3 4, it's all fine. If I say 0 1 2 3 4, it will give me the message the seed needs to be only 4 symbols long. Now if I do 3 symbols, the seed needs to be only 4 symbols long. Okay, that's perfect. That's exactly what I wanted to have. Moving right along. Now, we need to have the ASCII code of each individual character in the seed. So we have 4 characters in the seed, so I'm going to set up an array. 4 I equal 0, I smaller than 4, I plus plus. I'm going to name that array ASCII seed I equal 0. Now, else, in this array we're going to store the ASCII value of each symbol in the seed. I know I'm repeating myself multiple times now, but okay, now we're going to have this message if we're having more than 4 symbols in the seed. But if we have exactly 4 symbols in the seed, we're going to have else. We're going to have to set the values of the array to its proper values taken from the seed. So we're having for loop I equals 0, I said smaller than 4, I plus plus. The setting up in the beginning is kinda slow, then you'll see how actually simple the entire thing is. So we're just going to say ASCII seed I equals. Now we're going to check up the save files and look for strings. Strings character add. Ooh, I saw something else that could be even more helpful. Strings ord add. Checks a given string and return the character code for the character at given position. This is exactly what we need. This thing. It's perfect. This is exactly what we need. String ord at. The string is seed. I didn't know this function exists. It's really helpful actually. Now I believe the numbers here 1, 2, 3, 4, this is our default seed. I believe this number is also the position of this thing. And in the array, the first position is position 0, not position 1. So I think I need to have here I plus 1. I'm not entirely sure though. So I'm going to have to draw those here also. Draw okay, 4 I equal 0, I smaller than 4, I plus plus, draw text, X is going to start from 80, copy, paste, 25, I'm going to say ASCII going to start from 80. It's going to be 80 plus I times 25. I don't know, we'll see, we'll balance that. dy is going to be 25. And we're going to have here ASCII seed I. Okay, save. Let's see how that is going to work out. 1, 2, 3, 4. Okay, now we have 1 is 49, 2 is 50, 3 is 51, 4 is 52. Right, let's see if we have 5, 6, 7, 8. It should be 53, 54, 55, and 56. There we go. So it's working as expected. I just don't like the way they are. The upper numbers, the seed values, should be spaced as the ASCII values. So I'm going to close that. I'm going to go back here, and in the draw event I'm going to space them out accordingly. I'm just going to move this copy. I'm just going to move this draw text function in there, plus e times, it's going to be 32, 25 is not enough, 32, and we're going to have string character char at, the string is seed, and position is I plus 1. Okay, let's see if that does what I want it to do. There we go. Not really. I know what's wrong with that, and I'm going to fix it in a nanosecond. In the draw event, we're going to go and remove that line of code. Okay, save that thing. Okay, and now we're having exactly what I want. The seed number, and right under the seed number we have the ASCII code. That's exactly what I want. Now, we have entered the seed, the player have entered the seed. So now we have to start generating the actually important things. So the first thing on the table we have is our level count. Now, before we do anything, we need to limit our level count into a certain range. So we're going to repeat the generation code, the generation process, while level count is smaller than, let's say, 3, the minimum value of levels in the dungeon will be 3. The maximum amount will be, let's say, 7. So while level count is smaller than 3 and level count is larger than 7, we're going to have our generation code. So we need to come up with a solution that will give us our level count, and will be based on this ASCII seed values, because we have 4 of them. What I can do right now, I will need to incorporate the level count inside the equation, so I cannot use 0 as a value for level count, so I need to set it up. Level count I need to set it up to some value that is not 0. So I'm going to set it up to ASCII seed 1. Actually 0. Okay. Now we have level count will be equal to. What I like to do is use the integrated trigonometry functions because they always give me smaller number than what I have. So what I like to use is sinus, you know what I mean. It always gives me a number between 0 and 1, so it's either equal to its previous value or smaller than it. Between -1 and 1, I'm sorry, but I'm going to use its absolute value, so it's going to give me number between 0 and 1. So I'll put the equation inside here. And because I can't really have an ASCII code of 7 or something like that, I will just use the equation inside here. So the level count will be sinus of, let's throw something, pi. Pi times ASCII code 1 times SQRT 17 times ASCII code 3 divided by this entire thing will be divided by 7 times ASCII code 2, and all that thing will be multiplied by level count. No, actually all that thing will be multiplied by level. All that thing will be multiplied by level count. So if we start with, let's say that the ASCII seed 0 is, let's say 100. So we're starting with level count of 100, and this equation up to this point will always bring me value between 0 and 1 because I use an absolute value here. In that case, I can have 0.001, and this thing will not. Ooh. Plus, actually +2 will be fine. If I have 1 here, I need also to round this thing up. So this is where we can use the function floor. And alright, we need to round this thing up. So this thing this equation up to here can give me value of 0.0001, and if we multiply that by 100, actually it shouldn't be floor, because the floor will always give me, oh boy, okay, what was the other one? We need seal. I said seal. So if I have, from this equation, if I have 1 plus 2 will give me 3. Now if I have 2 here plus 2 will give me 4. It will get inside the range. Now if I have 10 here Plus 2 will give me 12. It will be outside the range, so I'll have to go through this entire thing again. It's very simple, although I can't quite explain it very well. Now in the draw function, I'll just draw another row of text. Draw text. 10, 40, 40. The text will be 4, 4, level, count. 8, okay, and now we need to draw text. 10, 40. Level, count. There we go. Right, let's test this thing. Because in my head it makes sense, it works, but I don't know if it... Okay. The visualization is not as good as I was expecting. Let's push everything a bit further away. Let's push it to 100. And see what's going on now. Is it going to visualize better? Okay. Level count 49. It shouldn't be 49. Why is it 49? See, this is why I do this visualization. Level count 49. Or. This should be or, not and. Okay, so let's try now. It cannot be at the same time smaller than 3 and larger than 7. And immediately I have... It's not an array. Okay, trying to index a variable. Line 23. Not an array. Okay. Trying to index a variable which is not an array. ASCII code. There is no ASCII code. There is ASCII seed. Right? Is that the issue? ASCII seed? Yeah. It's ASCII seed. Seed. It's ASCII. Seed. And here it's ASCII seed. Okay, let's try again. Save. This is going to be a long episode, isn't it? And it's going to be a boring one as well. Level count 4. 100 doesn't work as well, so I'm just going to push to 128. 128. 128. And 128. Okay, okay. Let's check it out now. This is going to be a long episode, but once this thing is done, everything will be fine. So now we have the level count of 4. If I change the seed to 4321, we're going to have a level count of 6. So this seed will give me a different amount of levels in the dungeon. Now if I put here 1111, I'll have entering main loop. If I put 1111, I have an endless loop, which is helping nobody. Alright. Okay, give me a moment here. Let's check the equation. You know what I can do? I can have a simple counter, and the simple counter will be counter equals 0. This will avoid the issue with and we'll avoid the issue with endless loops. Counter smaller than let's say for 25 loops I haven't reached the value I need. It means I'll never reach it. And counter. No, I don't want to put that in the same while loop. I want a separate while loop. So while those things are happening, and while counter is, god damn it, well, counter is under 25. And I'm going to also add 1 to the counter. Now, if this is an edge case, this is what procedural generation is all about. This is an edge case. We have an issue with certain values, and we need to fix this issue. We had an infinite loop, so we need to fix the infinite loop. If counter equal to 25, counter equals 0, counter. This thing should be over here, outside of the counter loop. If the counter is 25, the counter equals 0. It means that this thing has not reached its value. And we have the level. And we now need to check a couple other things. The level count is could easily be 0. The level count could easily be 0 and be killing the entire thing. You know what? For a second there, I'll just add 3 here in order to evade the possibility of the counter actually being 0, of the level count actually ending up being 0. So I'm just going to add 3 at the end. Let's see what's going to happen if I add the value, if I enter the value 1111 now. Now it's the endless loop again. Okay. So the counter thing is exactly what we need. Okay, if level count equals 0, if level count is smaller than 3, actually is smaller than 3, I said 3, level count equal 3. Else level count equal 7. There we go. Now, two. Now, if we have a level count that is smaller than 3, we have 3 options here. The level count will be either smaller than 3, will fit inside those parameters between 3 and 7, and will be larger than 7. Now, if it's smaller than 3, it will be 3. It will be set to 3 automatically by the system. If it's between 3 and 7, it will fit in here and will generate the dungeon. And if it's larger than 7, then it will be set to 7 by this rule here. So let's just check what's happening with the weird edge case that we found. I'm surprised I found an edge case so easily. Breaking point. Okay, 1, 2, 3, 4. It's 7. Space. 4, 3, 2, 1. It's 7. Weird. It's always 7. Yeah, I know why it's always 7. I should have. I thought it will do it automatically, but obviously I'm wrong now. If level count is larger than 7. So, okay. Okay, now let's. This should be outside. This should be on the outside, and this should be on the inside. And this should be on the outside as well. This should be on the outside as well, because we need this should be inside here. Yeah, that should be it. Okay, we want the counter to be counting how many cycles it took this equation to return an answer that is inside those limits between 3 and 7. If it took okay. We don't even need this thing here. We actually does not, yeah. We just need the counter. And with every generating cycle, we're checking the counter. And if it takes more than 25 turns and it hasn't returned a value, we're just restarting the value of the counter. There we go. Now this should be working this time around. I have used a different method every time I've been experimenting so far, and this is why it's weird for me to program it now on the fly. I'll try and edit out the boring stuff. Okay, so far it's working well. Let's see the 4-3. I said 4-3-2-1 value 6. All right. Now let's see the problematic 1-1-1-1-7. So it's been giving a huge number all the time, constantly. All right. How about 2-2-2-2? It's 7 again. I see. Now, most likely you'll have as a seed something like Q5, F, T or some random numbers and letters like that. You can even have those things as a seed. You know, it's weird. And that will give a different amount of levels. That will give you a different amount of levels on each floor. Now, 7 seems to be coming often, so I'm just going to put it larger than 6, and it's going to be 6 as maximum number. So I have 3, 4, 5, or 6. You know, it's fine. Now the next thing we need to generate. Okay. Now the next thing we need to generate is the level size. We can base it off of the level numbers, meaning the level count, meaning if we have large amounts of levels that will be shorter, or we can even make it longer, or we can not connect them by any way, which is exactly what I'm going to do. I'm not going to connect the level count and the level size in any possible way. We're going to have to set the level size into a certain range, let's say, as well. So level size will be smaller than, let's say we have 10 or 10 as minimum size and 20 as maximum size. Level size equal 20 actually is larger than 20. We're going to generate levels until we have the size between 10 and 20 blocks. And again, we cannot use, just like in level count, we cannot use a value of 0 that we have set. So we have to set it to something else. Now, level count we set to ASCII seed 0, so level size I'm going to set to ASCII seed 1. Okay. And from here I'm going to do this thing again. Level size is equal to level size times an absolute value of sin of let's say ASCII seed 0 squared right divided by ASCII seed 3 times square pi. I have no idea what I've just did. Plus 9. I also need to add all this counter malarkey as well. And this time I'm just, instead of level count, I'll use level size. Size smaller than 10. Size equal 10. size equals 1. Size, if level size is larger than 20, level size will be equal to 1. There we go. Okay. Save. Okay. I said save. And let's see how that thing is going to do. And I'm going to close it immediately because I haven't visualized it. Alright, haven't visualized it. Alright, copy, paste, 40, this is going to be 55, this is going to be 55. Level count will become level size, and level count will become level size. Right, okay, save, test. Okay, immediately abort. Alright, let's see what I've done so it doesn't recognize it. Level size, lever size, I see. Mistype, typo, save, misclick, sausage fingers, pressing too many buttons at the same time. Not said before reading it. Line 40. Ski seed 0. Program. Level size. Interesting. Oh, I see level C's. So bug fixing is the most boring thing in the world, but it's the most important as well. You want to fix all the issues that your code can possibly have. And this is taking quite a long time. I expected this video to be over already. 15.96. I don't like 15.96. So what I'm going to do here is go back and use the seal value of this entire thing. There we go. Okay, save. The seal value will give me an integer number. 1, 2, 3, 4, 16. Not 1596 anymore, it's going to be 16. Okay, now if I change it to 4321, we're going to have 18. If I change it to WASD, we're going to have 6 levels with 19 blocks each. Okay, that's quite an interesting thing. This is going to be a huge, enormous, huge dungeon. Okay, so far so good. Now, if you see a pattern already forming, you're not the only one. From that point forward, we need to generate the amount of chests and the amount of enemies, and it takes the same, absolutely the same approach as we already have done. So I'm just going to copy this entire block here, and we'll do this chest count. There we go. That's our dungeon. We have 4 levels, 1, 2, 3, 4 levels of the dungeon with 16 blocks each. Go, you can count them. 14 14 chests. We're currently having only 12 chests, which is weird. Why do we only have 12 chests? and 16 enemies, and the enemies are evenly spread all over the place. Okay. Oh, because we rounded the numbers. And this is why we have only 12 chests instead of 14. Right? Is that the issue? Rounded the numbers? Let's check the draw event. Yeah, rounded the numbers. Interesting. It's interesting how it... If I put that on floor, so it's rounding to the lowest number, will that give me better spread on the chests? It probably will give me an extra chest, you know, in other edge cases. Now I have 16 chests. Yeah, I better just use round. It's the best all-rounder after all. Round. Okay. And that's it. That's our procedural generation system working, kinda, sorta. Alright, let's use the WASD seed. So there we go, we have 6 floors. 1, 2, 3, 4, 5, and the 6th we barely see. We have 19 blocks on each floor. We have 19 chests. 15 on the first 5 levels, and the 6th level that we barely see have 4 chests. And we have 13 enemies, and everything is evenly spread. This is exactly what we want from our system. We wanted to give us different results with different seeds. And the thing is, the next time I enter the seed 1, 2, 3, 4, I want to or 4, 3, 2, 1. Let's enter 4, 3, 2, 1. This is interesting seed. You see that it kind of looks random. Now the next time I enter the seed 4, 3, 2, 1, I want to bring me the exact same result. There we go. If I enter the seed 1, 2, 3, 4, it brings me this result. If I enter the seed 4, 3, 2, 1, it brings me this result. And every time it brings me the same result if I enter the same seed. That's the thing we want. But different seeds bring out the different results, and that is what we want as well. That is what we see in the Binding of Isaac. So in the next episode, I'll try and start implementing this thing in the game that I've been making. This is very, very basic random generation, procedural generation system, but it does the job. As you can see, it's working. So yeah, if you have any feedback, leave it in the comments below. I'm sorry this video is going to be so boring and slow-paced and things like that, but this is not gaming, this is programming, and it takes time and it takes brain power. So yeah, that will be all from me for today, and next time I'm going back inside the game. See you guys.